Hi everyone. So today we'll be seeing work energy theorem for a variable force. So work energy theorem, as the term implies, it is the relation between work and energy, that is work done on a body and the energy change that is brought about in a body. So it can be stated that the work done on an object will be equal to the change in its kinetic energy due to the work done. So, how can we prove work energy theorem for a variable force? So, work energy theorem relates work and energy. So, here we'll be relating work and kinetic energy. It can also be a relation between work and potential energy. So, here basically for any work which is done on an object such that its kinetic energy changes from one value to another, then the change in kinetic energy will always be equal to the work done on the body. So mathematically we can write it as the work done on an object can be represented as W will be equal to kinetic energy, change in kinetic energy. Suppose Kf is the final kinetic energy and Ki is the initial kinetic energy, then it will be W is equal to Kf minus Ki. So how can you prove this theorem? So for that, let us begin with the rate of change of kinetic energy for any object. Suppose its kinetic energy changes during a time interval dt. How can you represent the rate of change of kinetic energy? So rate of change of kinetic energy can be written as dk by dt. Now we know the expression for kinetic energy, which is half mv square. So it is d by dt of half mv square. Now we have to apply a rule of differentiation here, where we have to differentiate this term. Here we have half and m as constant, so that can be taken outside. So half m into dv square divided by d or d by dt of v square. Now we know that v, velocity, is also a function of time. Then when you differentiate this, we have to go by the rule, that is when y is equal to u raised to n, if you have to differentiate u with respect to x, as u is a function of x, where u is also a function of x, then you have to differentiate in this way. Dy by dx is equal to n u raised to n minus 1 into du by dx. This is the rule you have to apply. So here we are doing the differentiation or finding out the rate of change of velocity with respect to time, and here on the left hand side we have kinetic energy with respect to time. So let us do it. Half m, go as per this rule. Here n is 2, so 2 v raised to 2 minus 1, so it will be 2v into dv by dt. Now this 2 and this 2 get cancelled, so what do you get finally is m into v can be replaced by dx by dt, and dv by dt can be replaced by, dv is rate of change of velocity, just acceleration, so we can write it as m into a into dx by dt is dk by dt. Now dt and dt can get cancelled on both sides, so what you get is dk is equal to m into a, mass into acceleration. Mass of the body we have considered as m, and acceleration of the body, it is the force acted upon the body, so it can be replaced by f into dx. Now this is the small change in kinetic energy for a small displacement of the object. So in order to get the total change in kinetic energy, we will have to integrate this. So integrating on both sides, so integrating on both sides, what do you get? Integral dk. Now when you integrate the kinetic energy, we have the limit, because the kinetic energy changes from initial value ki to kf. So we can put the limits, lower limit as ki, upper limit as kf. So this is the integrand symbol, which is equal to integral, so such that the position of the body changes from xi to xf. So on the right hand side, let us put the upper limit and lower limit as xf and xi into f dx. xi to xf of integral of f dx. Now, what is this xi to xf f dx? We have already seen in the previous topic. This is the work done by a variable force, so which will be equal to W. On the left hand side, when you integrate the small changes in sum up the small changes in kinetic energy, it will be kf minus ki. So we have proved the work energy theorem for a variable force. We have started with the variable force, saying that it is a continuously varying force which is acted upon by a body such that it changes, the kinetic energy of the body changes from an initial position to final initial value to final value. Then we started with rate of change of kinetic energy as dk by dt, which is equal to dE by dt of half mv square. Then rest is as we go or proceed according to equations or applications of differentiation, we can arrive, and after this we have to integrate in order to find out the total or the change in kinetic energy. Both sides we are integrating. On the left hand side we'll get the change in kinetic energy, on the right hand side we'll get the work done on the system. So this proves that the change in kinetic energy of any object due to the application of a force. So in this case, it's a variable force. Let it be a constant force or a variable force. It will be equal to the work done on that.